Hey everyone, and welcome to another Risky Business product demo. My name's Patrick Gray. The idea behind these demos is we get one of our sponsors on to do a bit of a show and tell, show us how their software or hardware sometimes works. And today we are joined by Feross Aboukhadijeh, who is the founder and CEO of Socket, which you can find at socket.dev. And Socket is a software supply chain security product for developers. But for us, I'm going to get you to give a more complete explanation of that.
Yeah. So we describe it as a developer-first security platform. We built Socket to help you protect applications from software supply chain attacks. Folks are building applications on tons of dependencies today, and we often see folks with thousands, tens of thousands of packages. And so that's what Socket's about, right? Is helping you proactively detect and prevent malicious and vulnerable packages from getting into your products.
So someone takes over a package, adds a bunch of malicious code. The idea is when you're in your software development environment, Socket is gonna flag that for you.
That's right, yeah. So we can do what like traditional software composition analysis tools do in terms of managing your open source components, your third-party libraries, detecting vulnerabilities. But the real kind of difference for us is, we go beyond just that traditional vuln scanning to do more proactive and kind of comprehensive protection against also emerging threats and software supply chain attacks in open source. So that things like backdoors, obfuscated code, typosquatting, and the use of kind of risk APIs. And then we kind of put that all together in a platform to help you manage and understand those risks, and then to most importantly, kind of get in there and influence the developers as they make their decisions, because that's really where a lot of this comes from, is the developers just doing their thing and installing tons of packages into your environment.
Yeah, so does this plug into your IDE or scan your repos or both?
Both, yeah, and even more. We do actually do some developer kind of interventions that I haven't seen anyone do before. So it's actually really cool stuff, as early as kind of you can get.
All right, well, let's get to the demo. Let's start at the beginning. Let's go.
Yeah, cool. So I'll get us started here. So the first thing I wanted to cover is just kind of how you install Socket, because I think it is really something that sets apart us from a lot of the tools in the space. The SCA space hasn't really evolved very much in the last 15 to 20 years. It's all just kind of the same old school vendors that we see a lot of. So when we started Socket 4 years ago, we wanted to make the install process as easy as it gets. So we put ourselves in the GitHub marketplace. And so if you're using GitHub or any of the popular source control tools, like most folks are, then getting us rolled out across the whole organization is literally 2 clicks. So a lot of people tell us it's like the easiest thing they've ever, the easiest security tool they've ever used. Once you've done that, we get visibility into every dependency in the organization. We do that without any scary permissions. We don't need to write to your repos or read your source code or collect any PII. We're not an agent that runs at runtime or anything like that. So it's really it's designed to be kind of easy to get going. And the most important piece is that we don't block developers, because I know that can be kind of one of the fears with a tool that integrates into the developer workflow, is you don't want to slow down a developer or affect that developer velocity as a security person, because then you lose that credibility with the team if the tool is too noisy or it doesn't work as intended. So out of the box, we won't block developers unless you want to. So it's very low risk.
All right, well, it's a demo, so give us a demo of the installation.
Sure, yeah. I mean, it's just nice to show literally how easy it is. So I just clicked install. It's asking me, GitHub is asking me which organization I'd like to install Socket to. So it's a matter of just clicking my personal org here, and we're going to go ahead and install it to all repositories. I need to do this is going to be fun. I'm not going to do that on the video. I'm going to log in with passkey here real quick. And just like that, we've installed Socket across this entire org with hundreds of repos in it. So once that's set up, Socket's now looking at every repository in the organization, and we see every commit that your developers are making on your main branch, as well as every pull request that they're opening and attempting to merge. And what's great about that is that means that right out of the box, we can create snapshots of SBOMs at every point in time throughout the evolution of your your repositories. So this means that you get, pretty great functionality in terms of just like understanding what dependencies you're using. One of the things that sometimes comes up is whenever there's one of these big headline grabbing attacks like Log4j or XZ, your CISO or your board might ask you, hey, are we affected by this? Or you might want to quickly find out, where you may be affected by this dependency. And so with Socket, you can just come over here and put in, the name of a package. Like let's just try safe buffer. This is a package that I'm a maintainer of. And so you can see here that, I'm using this package in 5 repositories. And you can get kind of the details here of all the repos, as well as the branch that the dependency is present on. And you can see the exact version as well. So if you have multiple versions and only one version is vulnerable, you get that data really quickly. So
I mean, what you said about the Log4j thing, it's so true, because there were so many companies, where staff were being asked, like, do we use it? And they're like, I don't know, So, I mean, and that was even just in their own applications, like figuring it out, like other appliances and software that you might be using. Like, yeah, that was a nightmare.
Yeah. So, I mean, this is going to just give you something out of the box that looks at those manifest files, those package JSONs and requirements.txts, all those files that the developers are using to specify the dependencies. And step one for our tool to work is we just need to understand that. And so we offer this kind of tool to give you that visibility across the org. Then the next piece is, okay, like tell me about the risks, right? That's what you want to know. So you want visibility into what the risks are of those packages. And you can see, it's pretty easy to kind of get a view here of what your risks are. And in fact, I'm just going to switch over here to a different org where I have a few more interesting alerts that I've created here. And let me just pull this up. So once you have Socket hooked up and we're pulling in all that data, the next thing you want to ask yourself is, what are the risks? And so if you come over here to the alerts tab, you can get visibility into the risks that are present in the org. So right off the bat, we can see we have a couple of malware packages in our environment. If we click in, we can see exactly what the threat is. So it looks like in this case, this package that we're using was downloading a pre-built artifact from a domain which was compromised. And it happened to be an S3 bucket that was being used to host an executable file that was part of this library. And that S3 bucket was abandoned and an attacker registered it. So anyone who had installed the package prior to this particular date here was affected. So this is kind of a not a great situation. Let's go to another example. This is a package here that we're using where the code appears to be collecting kind of a bunch of data and executing some shell commands. And then kind of doing a suspicious comparison. So this is something that our team is flagged as malicious, and that we're surfacing here. I'll go to one more example. This is a package which is running a post installation script. So this is code that runs automatically whenever this code is installed by the developer or when it's run on the build server, and it's downloading an exe file from an external source without any kind of validation or integrity checks. So it's basically loading malware out of this GitHub URL here and saving it and executing it. So
it's extremely not great, is what it is.
Precisely, yeah. So it's really quick. It's really great and kind of useful to be able to just get that visibility quickly. With 2 clicks, you can find out if you're affected by any of these packages. And the best part I'll just mention is you can do this. Without talking to our sales team. We obviously would love to talk to folks, but we've built the product so that the kind of free version of the tool gives you what you're seeing here so far right out of the box. So it's really easy to just find out whether you could get value from this tool by just trying it out. So
and I'm guessing too that the stuff we're seeing under that in orange, like the red stuff is malware, bad, get it out of there. The other stuff I'm guessing is a little bit more nuanced and might require a little bit more context to understand if it's a problem.
That's correct, yeah. So a lot of folks, when they first get started with Socket, they are just interested in the most severe findings. And they also, they're interested in the developer workflow pieces that we provide. I'll get to that later. But it's totally fine to just use Socket for blocking the most severe threats and then to kind of build up confidence over time by monitoring these other things. And then when you decide that the detection is valuable, to upgrade it to a higher level of intervention. So we have like 4 levels of intervention you can take, block, warn, and monitor. So out of the box, we've configured it such that you're blocking malware, you're warning developers about obfuscated code, protestware, any packages with unwanted behavior, and then there's various ways of loading code outside of the kind of recommended package manager workflow, which effectively allows the dependency to bypass kind of your lock file. Effectively, loading code off of an HTTP URL, for instance, is an example of a really bad practice, because if a dependency is doing that, then there's no way to get kind of a reproducible build or to know what you're being served at the time that you do the installation.
Just to be clear, though, because you're talking about blocking stuff, and I mean, in this instance, you're scanning code that's already in production, right? So, which I'm guessing you can't block it once it's in production.
That's correct. Yeah. So the security policy is really about it's most useful for how all the integrations that we offer work. So do you want to block the developer? Do you want to warn the developer? And I guess maybe I can skip ahead and just kind of show what that looks like, since we're talking about it now. Yeah, I think that might be helpful. So this is a pull request that I've gone ahead and sent here, and you can see it's adding support for this some open source utility that helps with browser compatibility. And what I want you to notice is, out of the box, GitHub and all of the different tools we use as developers don't really give much context on the threats that are in the dependencies that we're using. So this looks like a one-line change here, along with a config change over here. But this is really hiding the complexity, the amount of code that's behind this dependency. There's potentially hundreds of additional dependencies being brought in that are not shown here, because this is just what we call a direct dependency. And there's very little information about just whether this has vulnerabilities, or whether it's whether it has other problems, and whether it's like unmaintained, for instance, or deprecated, or has some type of threat within it. So what we do is, when Socket's installed, whenever a developer makes a pull request like this, Socket does two things. One, we provide what we call our dependency overview, which is a comment that is made by our bot automatically in line. And it explains to both the developer themselves, as well as anyone who's code reviewing this PR, that there are new dependencies detected in the PR. So you can see here this package has been detected, and we're also noting that it's using certain capabilities that may be risky. So the way I like to look at this capabilities feature is if you think about when you use a smartphone and you install an application, it doesn't just get to use whatever capabilities it wants. It doesn't get your mic or your camera or your contacts or your location just because it wants to. And certainly, it doesn't get to do that just because you upgraded to a new version of the app. But with open source, that's just how it works. Like, we don't really have a way for dependencies to declare their capabilities. And so when you bring in a new package, or when you bring in an update to a package, that's an opportunity for that package to significantly change its behavior in a way that could be detrimental to your environment. And so we want to just surface that here. And what you're seeing here is this dependency is using environment variables, meaning it's reading out keys potentially, or tokens from the environment. If you click this link here, you can actually go in and see exactly the line of code where that's taking place in the package. And that'll just load up here, and we can take a look at that and see exactly what environment variable is being used, and click into the actual code if we're curious. But so what this is really helpful with is just making sure that everyone is on the same page about what this dependency is doing, and to take toil away from the developer, because we can't really expect them to do this work and to do this type of investigation. It's not happening today, right? It's just it's not a thing.
Well, it's just amazing. Like the way dependencies spiral is incredible. I mean, I even remember like 20 years ago, like spinning up a new Linux box and just managing all the dependencies just for a basic Linux installation, right? Like, this is not a new issue. I think what is new is just the way software is developed these days. It's all dependencies on dependencies. And, there's a lot of stuff. It's like software soup that all gets, mixed together into some sort of, Yeah.
Yeah. So I'll show you real quick, if you'll tolerate a quick divergence here. show you a cool animation of just a single dependency and how that actually plays out. So this is a visualization of a package, a very popular one called Express. And every gray box is a package, and every purple box is a file within a package. And what you're seeing here is we're peeling back the layers and kind of going down that dependency graph one layer at a time. And you can see very clearly just how many packages are embedded within that initial package. And each of these packages potentially has a different maintainer, a different publishing process. They come from different countries of origin, and so that's just that's what we're dealing with here in the modern application development. This is another visualization.
Packageception, yeah.
Yeah, exactly. This is another way to look at it. This is visualizing what the package manager does when it installs a package. It sort of transitively has to kind of crawl the dependencies. It installs the first one, and that one declares that it has other dependencies, which declares that they have other dependencies, and by the time you're finished here, you have this mess just from a single package that you've installed. So you can see very clearly why we end up out of control with, some of our customers having, upwards of 50,000 dependencies in their organization.
Yeah,
it's wild.
100%. Well, and you're not gonna do anything about that without automation. Like, forget it.
Yeah, you can't expect developers to do this work. So what most folks have done, like most teams we see, they've just kind of thrown up their hands and said, what are we going to do? Like, we can't stop them from building apps using JavaScript. They need to use React and all these modern frameworks in order to get their job done, or so they say, right? and so they've just allowed it through. And maybe the most we've seen is folks using a vuln scanner and and saying, okay, if there's no vulnerabilities, then it's fine to use it.
Yeah.
But what we're looking at here,
well, I mean, that's what SCA has focused on, really, is been CVEs, vulnerabilities, and whatnot. Less so deliberately Trojaned packages full of obfuscated horror show code.
Right. And that's good. We see that as a baseline. Like, that's a great place to start, but not kind of the end game here. Like, it's especially now that we have tools to actually address this, tools like Socket. There's going to start to be less acceptance of not using tools like ours, frankly, because when an organization is affected by a malicious package, and there was a tool on the market that could be used to stop that, and it wasn't, I think we're going to start to see it become more of a norm, and then eventually become more of a standard that is built into things like SOC 2 and other types of certifications. But Pat, I want to get back to the second comment here that I have on screen, just to show folks, like, what does it look like when a developer actually sees a security alert inside their workflow. And what you're seeing here is we're calling out the fact that this package, browser list, is actually a typo. So I should have installed browsers list, not browser list. And it's an incredibly easy mistake to make. And the correct package actually has 2.3 thousand times more downloads. So this is how we're able to kind of identify this as a typo squat. And then this also tends to have this tends to be a technique used by attackers to hide really nasty code in their packages. So what you can see here is it's really easy to get the information, the context. There's lots of next steps and information here. There's even a way for the developer to actually request to ignore and therefore bypass this alert. So if you want to allow that in your organization, you can let the developer just come down here and leave a comment to tell the bot, hey, I'm actually going to ignore this alert for now, and I'd like to proceed. And when you do that, the check that you see here, where Socket is actually preventing this PR from being merged, will actually be bypassed, and it'll allow it through. There's a lot of configurability here in terms of how much you want to either just speed bump your developers, give them that info and then trust them, or how much you don't trust your developers and want to really tell them no.
Well, I mean, if they actually have to type a comment and hit a button that's going to be logged somewhere, that alone changes behavior. I mean, I've seen that in other products like allow listing solutions, like there's one, Airlock Digital. They got a similar thing. Users can go around the product, but once they have to sort of take additional steps to bypass it and they know that that's going to be logged, they're less likely to do it. It's different to just hitting ignore.
Exactly, yeah. And you've at least forced them to acknowledge the issue, right? They're not going to ignore the tool in that instance. Yeah. So Pat, what I'd like to do now is I'd like to just show some examples of the types of threats that Socket detects, because I think sometimes when we talk about supply chain security, it can be abstract, and I just want to show folks like what are some examples of recent attacks that Socket has detected. And so what I'm going to do here is I'm actually going to refresh this page, and we can see this is a live listing of threats that Socket has identified in various package management ecosystems. And you can see, let's just click on the first one here and see what it does. So this was something that was published an hour ago, and we detected it an hour ago. So like I mentioned, we're monitoring every one of these ecosystems, and we're able to identify these threats really quickly. The other thing I'll draw your attention to is it's actually live still, meaning that this package has not been removed, even though we've reported it to the package manager. It still remains live, and you'll just see if I scroll through this list just how many of these things are still live, going back weeks, months. Just shows kind of the amount of malware on these ecosystems is just out of control. So let's see, for this one here, what it's doing is it's doing data exfiltration by sending sensitive info to a remote server using encrypted and obfuscated methods. So we can click in here and just see for ourselves what is it doing.
I mean, that's an alert that, like, it's hard to read that alert and think, oh, that's fine. Like, as far as alerts go, that's a pretty, you don't really want to click continue on that,
Yeah, and that's kind of been our whole argument to folks is, look, like, even if you are suffering from alert fatigue and you are drowning in your CVEs, by the way, we can help with that too. We have a lot of things around reachability analysis and prioritization where we're trying to up-level above what the traditional vendors, the legacy vendors, are doing around CVE alerts. But even if you have a backlog and you're trying to work your way through it, it's worth thinking about, okay, are we just fixing these things because it's what's easy to measure? It's easy to know how many CVEs we have, and we're going to fix them, even though we know that 90% of these aren't real problems, that the code is not reachable, or the threat it's in a developer dependency that isn't going to run in production. It's the kind of thing that it's marked as a medium or high when it really should be a low. There's a lot of inflation of severities, unfortunately. So when you think about that, right, and you think about this type of alert we're looking at here, it's very clear that this goes to the top of the list, right? This goes above pretty much any CVE that you're going to have, because even for the really big CVEs, you still have to have an attacker come along and find that vulnerability and take advantage of it. So you do have.
I was literally thinking about that before, which is like, for a lot of the CVE scanning of projects, it's going to be bugs that, like, the people who are going to get to that are like really determined red teamers, doing a pen test of some transaction platform at a bank or something like that, right? Like, whereas this stuff, if you include it, you're done. It's a different type of threat.
Exactly. And so that's where the value comes from, is folks use us, they either add us on to their SCA tool if they're happy with it, or they fully replace it with us, and we do everything that a traditional SCA tool does, and then all this fancy, exciting new stuff, right, that protects you from the kind of latest.
Yeah. I'm not arguing that people shouldn't scan their repos for CVEs at all.
Right.
I'm just saying that this stuff is, guaranteed to give you a bad time, whereas CVEs might give you a bad time, of course, depending on the CVE. But anyway, I've taken you way off track. Please continue.
No, it's great. It's great. So I can just click through some of these other ones here. There's just so much interesting stuff that I just think, even if folks aren't ready to fully adopt Socket, go ahead and just link us up to one of your kind of a test repo in your organization. That way you can get access to the threat feed tab here, and you can just go through and look at some of these things because they're so fascinating. Look at here.
Sorry, I'm going to cut you off again. Sorry, but how often is it that people hook up Socket and they don't find anything? Because I'm guessing, anyone doing development at scale, it's going to find stuff, right?
Yeah, exactly. And, it might not find malware on day one. I mean, fingers crossed, right? You don't have malicious packages in your environment. But what Socket will do is, even if we don't find malware, we'll find things like packages that are exfiltrating information at install time, like collecting the host name and the company that's using the package. That could be innocent in terms of just analytics, but it could also be nefarious in terms of mapping out which organizations are using which dependencies. And so that's the kind of thing where folks want to know about it. There's also things we find which that are, again, are lower than kind of known malware, but that are still very important. Things like we've seen developers at the company who've forked a popular package in order to fix a bug in it, but then that developer leaves the company and they're no longer at the organization, but yet the dependency remains. And so that gives that former employee access to the supply chain in some way of getting code to run at their former employer even after they've left. And depending on the way in which they left the company, right, that can be more or less problematic. So that'll often flag as an unpopular package, or have other types of problems in terms of just the way that it's a fork. That'll flag as something that we want folks to look at. But the list goes on. Really, it's really quite a lot of really useful things, including the other one is. We have some companies that they're so good at managing their vulnerabilities, they've gotten the backlog down and they have a great process. But even for them, they want to know, hey, are we using unmaintained packages that, were they to get a CVE tomorrow, there would be nobody around to actually fix them. They want to get ahead of that tech debt. And so this is actually another great type of alert that you can get even with if it's not malicious, right? So there's just a lot of like extra kind of color and context you can get from Socket.
Yep.
Cool. Yeah. Well, what I wanted to do now is I'll maybe just take another couple minutes and just show folks a few interesting examples of some other recent threats, just to give a taste, and then we'll get into a little bit more of the product. But here's a package that actually exfiltrates your Etsy password file to an IP address using curl.
That's pretty blatant. You're not even trying to hide, as you said. That's
not even trying to hide. Yeah. Here's one that is. Using, let's just see what the note says. So it's using, it's collecting a wide range of system information, including SSH files, so the .ssh folder, and sending it to a remote server. But what I like about this example is it's not just doing an HTTP request, it's using a DNS query and putting the data that they want to steal into the subdomain of the DNS lookup. And so it bypasses a lot of HTTP-based firewalls and other types of detections.
Yep. DNS tunneling, kind of.
Yep.
DNS-based exfil. Nice.
Yep, exactly.
It's not dumb if it works, as we say.
Yeah. Here's one that's targeting, it looks like Wells Fargo. This is probably a dependency confusion attack where someone was able to figure out that this is the name of an internal package at that organization. And they published a package with the same name to the public registry so that when when internal tools go to install the kind of internal private package, if there's ever kind of a mistake or a misconfiguration and the public version is installed, they're going to get remote code exec on the system. So and they're again using that to do the same attack as the one I just showed in terms of stealing SSH keys.
Yeah, this is not stuff you want in your software projects, I think is safe to say.
Yep. Some of this stuff, I'm showing the ones that are easy to show on screen because they're not heavily obfuscated, but there's stuff like this that's even trickier. So this one is just kind of blatantly downloading an exe file from an IP and running it. Here's one that is using curl to kind of download a Perl script and then run the Perl script, pretty blatant. Here's one that is using shelling out to basically create a reverse shell using kind of a bunch of piped commands here that basically connect to this domain and then pipe the returned response into bin /sh here. And then here's one where they've been a little bit more clever and they're actually doing the piping to create the reverse shell in code. So that's interesting. Here's one where they've attempted to obfuscate the code. So you see that they've split the strings up. They've tried to evade static analysis with this type of array-based kind of joining the array together technique. It didn't really work to get past socket. We picked up the obfuscation. We figured out that it's dynamically creating functions that end up stealing the environment variables. So even though it's obfuscated, we've actually been able to figure this out. And this is part of the power of the kind of LLM-based architecture we've created. It's a hybrid of static analysis, metadata analysis of the package, the maintainer and the package behavior, and then finally an LLM to kind of tie it all together. So we're able to get these great results.
Well, I mean, as you point out, right, like most of this is not subtle. Mm-hmm. Like it's not going to be that hard to find if you're looking. I think that's the key thing.
if you're looking, exactly. Here's another one that's just an encoded command passed into PowerShell. So, just wanted to give people a flavor of just how blatant some of this stuff is. Obviously, there's more interesting examples, and I have some talks online that you can look up if you want to see me break down a much more complex example. But just to show folks, like, this is happening, this is real. A lot of these packages are still live, and it's something you do probably want to have some plan for, some answer to how do we not get owned like this.
All right. Well, let's continue with the product demo, because I feel like we're in the home stretch now.
Mm-hmm. Yeah. So we talked about kind of how to look at alerts, how to kind of understand what dependencies you're using. We've looked a little bit at the security policy. What I want to show now is we also do licenses. So this is something very important for an SCA product to do. Licenses is often not done very well. It tends to be something that is an afterthought in a lot of these products. We've built the most comprehensive license scanning tool that I've seen. We've compared ourselves to a lot of the open source tools out there and other vendors, and I have to say I think we've done a really great job here. We support over 2,000 license types, and we do a very deep license detection. So if a maintainer has sneakily changed a word in a license to add a not or a no to the license, completely changing the meaning, we're going to pick that up. If they've embedded the license into a source code file, that's something that we're going to detect, and that'll show up in the alerts tab over here as something that you're going to want to flag. So there's a whole category for license violations, and you can click in and just sort of see exactly what license is being used that's not allowed to be used in the organization. So very important functionality. So now what I wanted to switch gears to is, so we've kind of covered the security team's experience, and I did show a little bit of the developer experience on GitHub. But one of the ways that Socket really shines is we have a whole bunch of really differentiated integrations that allow us to get ahead of these threats before they're brought into the environment. The reason why we focus so heavily on this is that at Socket, we're really into this sort of stopping malicious packages, and a lot of the CVE scanners out there, because they're just focused on vulns, they do this thing where they just do like a scan every 24 hours of your production code and report on what they find. They're not really trying to influence the developer behavior. So what I'm going to show you now is literally the furthest shifted left that you can go in terms of a product, in my humble opinion. So what I'm going to do here is go to ChatGPT. This is something that a lot of folks are using today, whether it's through a Copilot or through Anthropic, Claude, or ChatGPT to kind of write code. What I'm going to do here is I'm going to just say, let's write a React login component that validates the email address is valid and that the password is at least 12 characters and sufficiently complex. How do you spell this? Sufficiently complex. So this is just an example of something that a developer might do to kind of get some code going that they can copy paste into their editor. And so it looks like ChatGPT has given us a nice bit of code here, doing some sort of client side, React to show to show a nice login form on the page. But it's also asking us to install a library called LTVal to validate the email address and password. And you can see here in the code, it's importing the LTVal library and then using it, in line here to check the length and the casing, et cetera, of the password. And what most developers do when they see this is they'll just kind of copy this code in and paste it into their editor. But what Socket's able to do here, because we're running in the browser as a web extension, we're actually able to underline this package with a red underline. And when you hover over it, you can see, first of all, it has a pretty low score. And then it's also known malware, and it's also very unpopular.
Thank you, ChatGPT.
Yep.
Our AI future is here, and it's terrific.
This is the thing that folks don't realize with these tools is they're trained on the internet, right? Like they're trained on Stack Overflow answers from 15 years ago, from blog posts from 10 years ago, right? They're trained on every bit of code that's out there, and a lot of that code isn't very good. On top of that, these are dependencies that may have been good at one point in time, but if they're not maintained anymore, or they've been compromised, or they're unpopular now, or something like that, this is something we want to know. Just because the model suggests that we install it doesn't mean we want to go ahead and install it. And so what I love about this is it's really, really clear for the developer here that there's an action to take. And we can surface it, as early as possible before they've even written, a single line of code. We're not waiting for it to get to prod. We're not even waiting for it to get to GitHub. We're doing it before they've even decided to use this package. So they can follow up and say, hey, can you give me a different package? And so on and so forth.
Yeah, I'm just as a side note, the week that we're recording this, there's been that graph going around about Stack Exchange traffic just dropping and dropping and dropping, right? So, everyone's using these tools now, and they don't always do a good job.
Exactly. Yeah, so what I like about this integration is that it follows the user around the web. So, it doesn't matter whether they're going to Stack Overflow or whether they're going to a blog post or they're going to Twitter. Whenever we see an install command anywhere, we're gonna inject this context. We've had several really large organizations actually roll this out across their whole engineering team using Google Workspace or Chrome Enterprise. It's very, very easy to just pre-install an extension on everyone's machine to do this, and so then they can click from anywhere on the web and get all the context that Socket provides.
Yeah, nice.
Yeah. So the next thing I'll just show here is just a couple more, just to kind of wrap this up, is say the developer were to follow that anyway and ignore the alert there, and just go ahead and install that package. We want to also have some way to stop that if we can, and so we do provide what we call safe npm, and also we do the same thing for other ecosystems. So safe pip, safe NuGet, safe Maven, et cetera, et cetera. And when you use this and put this onto the developer machine, you get something that looks like this, which is when the developer goes to install a package, if it contains a risk that violates, again, your security policy and your goals with what you want to enforce across the org, the developer will either get warned or will get blocked from proceeding. So in this case, they typoed the React package. They typed Reacts instead. And I don't know if you've ever done this, Pat, but it's happened to me many times where I'll actually be typing really quickly and I typo a package installation, and then I go Control-C, 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 and I hope that nothing got installed. But it's not a very, it's not a very reliable method. I have to notice it and I have to be really fast on the Control-C to try to stop it.
Yeah.
So this is really, really powerful. It's sort of like a safety blanket. You can just put it on your system, and then if something's really, really horrible in one of these packages, we're gonna warn you.
Yeah, I mean, that makes a lot of sense, right? Like, that's a good thing to do. Catch it early before it's actually all over your box.
Exactly. And it's implemented really cleanly. It's just a CLI tool, and we just alias, the package manager name so instead of running npm, it runs, whenever the developer types that, it runs socket npm, and that's all.
Yeah, I mean, you've got to rely on your developers actually doing that, though, right? Like, setting that up. Yeah.
Sure, but you can also put it into a kind of a standardized container that the whole company uses, or we also see a lot of folks using these cloud-based code sandboxes where they have kind of a remote environment that's clean that the developer uses. And so if they have something like that, it's actually quite easy to put us in there, and then everybody just gets it.
Yeah, that makes sense.
Yeah,
that makes sense.
Cool. And then the last bit I'll just show here is say that they ignored that warning and they proceeded anyway. I just want to show kind of what it looks like when it gets to the editor. So what I'll do here is I'll just import a package here that I've gone ahead and installed. So there's a package that I've already installed, and I'm just going to go ahead and start using it now. It's called Browserify. Well, it's supposed to be Browserify, but I'm going to go ahead and typo it here just to give you a really simple example. And what you see is Socket is putting inline context here to let you know that this package has many problems. It's not very popular. It's a typo. It's similar to other popular packages and may not be what we want. It has a license that isn't allowed at our company. It also includes undocumented or hidden behavior unrelated to its primary function, and it's not popular. So, what I love about this is that developers tend to be very OCD, and so as they're just going about their business, like working on, different parts of the project, whenever they go and look at a dependency, if there is a risk in the dependency, they're going to see this little icon, and they're going to, the good developers are going to ask themselves, hey, do we really need to be using this? Or hey, can I upgrade to a different version? Or how can I resolve this? And it's just surfacing it right there in there.
Yeah, need to make the red dot go away. Don't like red dot, make go away. I get it.
Exactly.
Yeah.
And then, kind of the last piece is just the PR workflow, which I've already demonstrated. So if we make it through the web extension, they ignore that. We make it through the CLI wrapper, that's kind of that safety blanket. If we make it through the VS Code editor, we push it up to GitHub. Then they have this kind of last ditch to try to stop the package from getting in before it's too late.
Yeah.
And then, of course, if it does get in, right, then that's where we do the whole kind of the visibility that we already demoed here, which is the whole dashboard experience. So we kind of cover the whole life cycle of the developer from the very beginning until the code is running in production.
Belt and suspenders, I think, is what the marketing people would call this, right?
Exactly. Yeah, so that's basically, that's a great tour of the platform, and hopefully gives you a sense of like, what we're doing, why is it different from other SCA tools, and like why we think we should call this next gen SCA, is that it's sufficiently different from what came before, that it actually probably merits its own name, its own category of product. I mean, people are using supply chain security as kind of the headline for that, but let me know, Pat, if you have a better idea for what we should call this kind of next gen SCA.
Let me think on it. I'll see what I can come up with. Well, Feross, thanks so much for giving us an overview of the Socket platform. As I mentioned at the intro, people can find it at socket.dev. Very easy to trial, so you may as well grab it. Throw it against your repos and see what falls out the other side. Could be it's either going to be reassuring or not so reassuring. So probably a good thing to do. Feross Aboukhadijeh, thank you so much for taking the time to walk us through Socket's platform. Appreciate it.
Thank you, Pat. Appreciate it.